Conceptualizations of learning in the learning sciences and STEM education. I assume all of you know what the learning sciences are by now. And so I'm going to go through my dissertation, what I did, how I did it, and what I figured out. My committee, Brian Smith, Penny Hammer, Christy Kelly, Ayanna Allen, and Dr. Mary Busey from Western Oregon University. So, simple form of the problem is thoughts lead to actions, conceptualizations of learning lead to practices in teaching and learning. Let's get a little bit more complicated than that. So here's my theoretical framework. So in a lot of pilot studies and working up to this, I developed this framework. I have no better name for it, so I've been calling it the iceberg framework for conceptualization analysis. There's an iceberg picture there, and the important part is there's above the surface and below the surface stuff. And what that looks like in terms of learning is analogies, surface metaphors, and experiences lead to conceptual stories and conceptual metaphors, which filtered through worldview and paradigm lead to conceptualizations. So then these conceptualizations create a set of action, linguistic, perceptual, and valuation potentials, thus impacting practices, communication, cognitive filtering, and values. And we'll get into what that means in a bit. But the research questions were, how do learning scientists and content area professors in science, technology, engineering, and math fields conceptualize learning? And what patterns of similarity and difference between these two groups are there in terms of conceptualizations of learning? And then how do the conceptualizations of learning relate to beliefs regarding practices in teaching and learning? And how does context mediate this relationship? And what conceptualizations of learning align more closely with evidence-based, high-impact practices from the literature in classroom-based teaching and learning than other conceptualizations? So the research design was, I interviewed 10 learning scientists. These are influential and founding members of founding people who founded the field of learning sciences and or are very influential in the field, and had to fly all over the United States interviewing them. In-depth interviews, about an hour, sometimes up to an hour and a half, just asking them what is learning and just talking about it. And did the same thing with 10 STEM professors. Research methodology, I used comparative case study, conceptual metaphor analysis, that's like Johnson stuff, grounded theory analysis, and critical metaphor analysis. And as I go through the results, then you'll see what those mean in terms of the study. My research paradigm, interpretivist ontology, constructivist epistemology, and then my methodology is qualitative. There's my research design logic, a little complicated, so I'll break it down a little bit. First, I did my 20 interviews, and then I did the first round of coding. I was coding for surface metaphors, characterizations that are non-metaphorical of learning, teaching, knowledge, value statements, and statements regarding the purpose of education. Then I deleted all the coding that I had done, keeping my code book, but I deleted all the in the transcripts, and I did it again, just to see if I agree with myself. And then after that, I did the conceptual metaphor analysis, and the way I did that was co-occurrence frequencies and correlations, and then some cluster analysis. And finally, mapping the relationship between the categories that I found, the conceptual metaphors, practices, non-metaphorical characterizations, values, purpose of education. And finally, comparative case study. So up till now, I didn't differentiate between learning scientists or STEM professors. At the very end, then I said, all of the stuff I found, how are they different between these two groups? So for the analysis, I had 132,000 something words, 571 codes. Check out my code book. 3,837 coded segments. And I did this twice, right? So I agreed with myself pretty well. My kappa for STEM professors group was 0.7, and for learning scientists was 0.68. I tend to argue with myself, but sometimes I agree with myself, yeah. And then I created co-occurrence matrices and correlation matrices, which then I was able to turn into semantic network maps. And I'll show you what those look like. So we'll start into some of the findings now. That's one of the semantic network maps using NetDraw and UCNet. So mapping the, this is just the metaphors. And the ones that appear here in this network are only the ones that are significantly correlated with each other in that massive, huge amount of data. And so the software that UCNet is able to figure out which ones are significantly correlated, and then what is the correlation like. So the distance between them is how far they are, and the strength of the line is how frequently they appear together. Two things appear together. And then more qualitative, I found two clusters for these conceptual metaphors. On the left, I found a cluster which I'm calling the acquisition and object manipulation conceptual metaphor of learning. And on the right, there were two of them, qualitatively different, but quantitatively no differentiation. A construction conceptual metaphor and a becoming and apprenticeship conceptual metaphor. But because they're so closely related, although they are different semantically, but they appear together all the time, so I collapsed them into one. And that leads us to taking a side trip, talking about complex systems. So this here is an anthill. I don't know if any of you work with complex systems theory, or also, it goes by several names, dynamic complex systems. But the idea is that there's an anthill, and in the anthill, there are amazing structures. There's ventilation systems, there are waste disposal systems, there are nurseries, there's even some farming going on inside of there. But none of the individual ants has a clue what's going on in terms of the larger structure. All of that is emergent from the interactions within that complex system. And so that's the approach I had to take with that complex. You saw the network map, it's pretty complicated. It gets more complicated. So I found two conceptual metaphors that are not caused by, but are emergent from the interactions between experiences, analogies, and surface metaphors. The two conceptual metaphors are acquisition and object manipulation conceptual metaphor, and construction, apprenticeship, and becoming conceptual metaphor. And we'll look a little bit closer at what that means in a moment, but first, the non-metaphorical things. So all of that so far was metaphorical only. So I ran the same kind of analysis on non-metaphorical things. And you see it looks similar to the slide previously about metaphorical characterizations. So the non-metaphorical characterizations, again, it looks like there's two clusters, right? And indeed, I did find two conceptual stories. I'm calling them conceptual stories. Conceptual metaphors are metaphorical, conceptual stories are non-metaphorical, but they operate very similarly. These conceptual stories were object possession, like learning is object possession. And the other was situated becoming. Learning is becoming, situated in your context, becoming. I also found two worldviews with social framing, individualist competition worldview and the collaborative cooperative worldview. And two paradigms, that's the more ontological, epistemological framing, positivist or post-positivist, and interpretivist, constructivist. And those together, I found two conceptualizations of learning. Beautiful, huh? Oh yeah, anthill. Definitely anthill. But in the anthill, there's these two, you see on the left and the right, there is some, you can see that there's something different going on both sides. What are they? There are two conceptualizations of learning. There's a transfer acquisition conceptualization of learning, and then there's a construction becoming conceptualization of learning. And so that's what it looks like in that iceberg framework. We won't go into all the details here because that would take a few hours. But in short, the transfer acquisition conceptualization of learning kind of defines learning as the acquisition and manipulation of knowledge objects. And these knowledge objects are descriptions and explanations of reality, which are the result of logic, rational thinking, and scientific processes. The role of the teacher is to transmit knowledge through various content delivery practices, including lectures and well-designed problems or projects and textbooks. And because knowledge objects can be quantified and measured, learning should be assessed in terms of the degree to which learners' knowledge aligns with the truth, as well as the quantity of knowledge objects they have accumulated and are able to manipulate. On the other hand, the construction becoming conceptualization of learning sees learning as becoming and construction of meaning. So learning involves participating in a community of practice to individually, collaboratively, and collectively construct and reconstruct knowledge. Teaching in this conceptualization is a process of learning experience design, so designing experiences for learning, mentoring, and developing a community of practice. Learning cannot be measured directly on tests, but teachers give continual feedback and help learners develop self-assessment abilities. So those are the two conceptualizations of learning. Now, how do those impact our practices? Well, in a complex system, my anthill, it's not a direct linear relationship. It's not direct causality between your conceptualization of learning and what you do. Remember in the first slide I said thoughts lead to actions? That lead to looks linear, like a direct relationship, but it's in a complex system, it's not linear, it's emergent phenomena. And the way we get there in this, what I found was that there are a set of potentials. There's action potentials leading to practices, and those are the range of practices deemed most appropriate in a certain situation. Linguistic potentials, the range of terminology, the words we use, deemed most appropriate. Perceptual potentials, that's the range of perceptions deemed most relevant. And valuation potentials, a range of possibilities for determining value or importance, like what's important here. And we don't need to go through all of these, but you can see they were mapped out, the action potentials in the transfer acquisition and conceptualization of learning, and the action, linguistic, perceptual, and valuation potentials for the construction becoming conceptualization of learning. I wish we had an hour and a half, we could really dive deep, but so those were the emergent, leading to emergent phenomena, which are the practices, the things that you do. So the potentials, the action potentials lead to the practices. The linguistic potentials lead to the communication, words you use when you're talking about teaching and learning. The perceptual potentials lead to this cognitive filtering. The statements indicating what I can see in the data was statements indicating what appears relevant, valid, or worthy of attention in teaching and learning. And values, that's the things I found in the data around statements and enactments regarding what is valued or important in teaching and learning. So that's how we get from conceptualizations of learning to the above the surface things in this iceberg happening here. Stuff happening below the surface, complex system, hard to study, but if we approach it as a complex system, we can find interesting things. But most interesting to me were the practices. In the transfer, acquisition, conceptualization of learning, practices emergent from that conceptualization of learning included lots of exams, grading, textbooks, clickers, lectures, content knowledge work, homework, worksheets. Sounds like fun. No? And then you can see my bias showing. Anyway, of course. And then in the construction, becoming conceptualization of learning, we see a lot of talk about the interest-based learning, real-world impact work, community of practice building, perspective-taking, critical work, self-evaluation, reflection, design work, relevance, exploration. That's just a sample of some of the things. The list is a lot larger than that. But here's an interesting difference between the two. In the transfer acquisition conceptualization of learning, cooperative learning versus in the construction becoming conceptualization of learning, collaborative learning. Often these words are used interchangeably, but if you look around in the context of what we're talking about, in the transfer acquisition, it's people working in a group, but each is doing their own thing and contributing to the group. Whereas in the construction becoming, the group as a whole is working it out. It's not individual, go do something, bring it back, contribute, okay, I did my part. It's like collective thinking and thinking together and working together. Another difference between these two that was very interesting was problem solving. In the transfer acquisition, there was teacher-directed problem solving, whereas in the construction becoming conceptualization, there was learner-directed problem solving. Of course, it's not always that clear of differentiation. Sometimes there's a middle space there, but in general, that's the way it was in the context of what the people were saying in these interviews. And now we get to the comparative case study, looking at the learning scientists and STEM professors. This is the transfer acquisition conceptualization. And as you can see, 96.7% of the data that was aligned with the transfer acquisition conceptualization was from STEM professors. And 3.3% of the indications in the data of transfer acquisition was from learning scientists. In other words, STEM professors tended to use the transfer acquisition conceptualization of learning. Here's the construction becoming conceptualization of learning. As you can see, 95.7% of the instances in the data when it was related to this construction becoming conceptualization of learning, it was learning scientists. And 4.3% it was STEM professors. In other words, learning scientists tended to use the construction becoming conceptualization of learning. And now to the practices that they endorse, the learning scientists and the STEM professors. There's too much there to really make any sense of this. But basically in the blue bars on the left are the STEM professors. And in the orange bars on the right, those are the learning scientists. And in the middle is shared things. And along the bottom, those are all different practices that were endorsed. But just look a little bit closer at the left side, the STEM professors, zoom in. So they talked about these things a lot. And you can see the things we mentioned before, like textbook grading, worksheets, teacher-directed problem solving. But there's a few interesting ones in here, like student-teacher interaction. So why weren't learning scientists talking about student-teacher interaction? So this is very interesting. This is only about things they mentioned, things they talked about directly. And the STEM professors are very interested in the student-teacher interaction. However, in the context of their discussion of student-teacher interaction. It's often in the form of, I'm lecturing, I pause the lecture, I ask a question. Now we have student-teacher interaction. And so maybe that's why it's not mentioned as much with the learning scientists. And then on the right side, there was the learning scientists. Zoom in a bit. So they were talking about a lot of things, but the most important one to learning scientists with the highest frequency was interest-based learning, followed by design work, having students do design work, and agency in learners, and collaboration, those sort of things. And the rest of this you can read in the dissertation. Cool. And then in the middle there were some shared things. And I think these are really important because these are things I like projects and discussion, productive failure, learning by doing. Those things are shared by both the STEM professors and learning scientists. They're both talking about these. And so I think that's a good middle ground for us to use when designing things or working with people who may have a different conceptualization of learning than I do. And then another research question was about the high impact practices. So the way I did this is I just did a lit review of the important publications, like from the National Academies, National Research Council, and the important documents in high impact practices. And those blue things up in the top, we don't go through all of them, but everything at the top is the high impact practices. And in the red down at the bottom, those are the practices that those documents say we should avoid or minimize. And then I made two scales, qualitative, but it's important for translating this. So on the horizontal here axis is individual cognitive focus of practices and the action potentials of those practices, to distributed or social practices. And then on the vertical there, abstract, objective, and reactive, to concrete, contextual, intersubjective as a range. Qualitative, not quantitative, looks like it, but it's not qualitative. And then I placed each of those practices from that chart, remember the blues and the reds, placed each of them in this quadrant matrix. So what does it look like? Those are the practices in blue that are considered high impact practices. And then in the red, those are the practices that we should minimize or avoid. That's interesting in itself, but here's something that's more interesting to me. That in yellow is the construction becoming conceptualization of learning. The action potentials emerging from the construction becoming conceptualization of learning. And in the purple, that's the transfer acquisition conceptualization of learning. The action potentials, the practices that are emergent from that conceptualization of learning. In other words, most of the high impact practices are exclusive to the construction becoming conceptualization. And most of the practices that we should minimize or avoid, according to literature, are exclusive to the transfer acquisition conceptualization of learning. What we make of that is up to your interpretation, but that's interesting to me. And then critical metaphor analysis, but first the definition. I'm going to here's my definition of critical pedagogy and empowerment from the critical theory work. Critical pedagogy positions learners as agents of social change and activists for social justice. In order for learners to inhabit these roles, critical educators place emphasis on helping learners develop the ability to investigate the lived experiences and unique perspectives of those who are oppressed and marginalized. Empowered and civically active learners develop understandings of themselves and their learning context as sites of agency, autonomy, and authority. This can only arise when they engage in critical analysis of systems of power, particularly regarding questions about who exercises power to create, curate, and certify knowledge or truth. So using that definition is how I did my my critical metaphor analysis. And here's what I found. The locus of agency in the practices. In the transfer acquisition, the locus of agency was external to the learner. Whereas in the construction becoming conceptualization, the locus of agency was internal. And there was also less of a separation between the teacher and the students, whereas there's a stronger separation in terms of agency, authority, power in the transfer acquisition conceptualization of learning. So some implications. The STEM education and the learning scientists. The STEM professors group were using the transfer acquisition and conceptualization of learning a lot. The learning scientists group were using the construction becoming conceptualization of learning. Practices. Emergent from the transfer acquisition and conceptualization of learning are some practices as indicated by our picture there, lecture. Those sort of practices are emergent from this transfer acquisition. It makes sense. If you think learning is acquiring information, then you as the teacher are going to do your very best to help your students do that. So you will give them the information, and then they will acquire it, and then you did your job. Whereas the practices in the construction becoming, if learning is becoming and constructing meaning, then you as a teacher will do your very best to help them become who they're going to be, who they want to be, and to be experts in whatever domain that you are expert, which means mentoring them into your community of practice. Other implications. This study, Anthill? Yes, complex systems is I found it to be a very powerful approach to studying conceptualizations of learning. And probably conceptualizations of other things as well, but that's not this study. And contributions to conceptual metaphor theory. So Lakoff and Johnson's conceptual metaphor theory said that conceptual metaphors are the direct result of clusters forming around surface metaphors, like time is money, wasting time, spending time, those sort of things. This time is money conceptualization, direct linear relationship, causality. However, this study found that those conceptual metaphors are very, 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 very important, but they're not the only thing. They're part of a larger complex system, including a lot of other things that we have to take into account. Also, found that my iceberg framework, those are the steps on how to do it. We won't go through them, but how to do conceptualization analysis in this iceberg framework. I found some interesting things as a result of it, which means for me, it was very insightful using this framework. And finally, in terms of critical pedagogy, and here's where you get your stones out and start throwing them at me. Either the transfer acquisition or the construction becoming conceptualization of learning can contribute to just status quo power structures and dynamics. One doesn't work better than the other. I mean, both of them can be equally problematic in terms of just everything stays the same in terms of power. But critical consciousness, empowerment, and social justice only can be most powerful emergent within the construction becoming conceptualization, not in the transfer acquisition conceptualization. And disempowerment, oppression, and marginalization can easily happen in transfer acquisition conceptualization. Okay, throw stones at it. Nice. Recommendations for practice. Align your designs for learning with your conceptualization of learning. Make your conceptualizations of learning explicit. Be intentional about your use of metaphors and terminology. And always think carefully about how you phrase what you're talking about, because other people may be using the same word with completely different meaning. Engage learners in questioning their own assumptions in their conceptualizations of learning. Focus heavily on class level work and assessments, and minimize individual level work and assessments according to high impact practices that we were talking about here. Mentor your students into your communities of practice, plural. We all have multiple. Engage learners in design work, and this is clearly from the learning sciences. Learning sciences is heavy on design work. Situate learners in positions of agency and authority, and leverage the conceptualization of learning by doing things like this collective knowledge building, real-world impact work, identity exploration, interest-based learning, questioning assumptions, interrogating power. Limitations, got a bunch of them, but so qualitative, it's qualitative data, it's qualitative analysis. You saw a bunch of numbers. It's not a quantitative study. It's a qualitative study. Interesting. And so therefore, we're not even trying for generalizability in this study. And small sample, only 20 people, so limited distributive power. And this clustering analysis is a bit reductive in that it doesn't take into account, it kind of weeds out a lot of noise, but in doing so, it's probably weeding out some important things. And then researcher bias, you probably know where I stand, but that influenced everything I did, of course, in this study. My data collection, my analysis, when I was coding things, filtered through my lenses. And final thoughts. Conceptualizations of learning matter because what we do as educators, researchers, and learning experience designers is emergent from how we conceptualize learning. It's also important because what our learners do as learners is emergent from how they conceptualize learning. Conceptualizations of learning matter because changing practices requires changing conceptualizations of learning. And finally, critical pedagogy work requires interrogating conceptualizations of learning, even our own, constantly. That's what critical pedagogy is all about. I want to thank my committee and my advisor, Brian Smith, my committee, Penny, and Dr. Busey and Christy Kelly. I want to thank Dr. Susan Gasson. She helped with the grounded theory stuff. And Dr. Elizabeth Camp. She's over at Rutgers. She helped with the conceptual metaphor analysis. And Dr. Mindy Donaldson, that would be my mama. She paved the way for me getting here. And my PhD cohort, thank you guys. And very, very deeply, I want to thank those 10 STEM professors and 10 learning scientists who gave me their time and wisdom.